I like. Okay, well, I guess we can go ahead and get started. And as people um, come in, they can jump into the session. This is a very exciting day. This is our second edition of the leadership series for class 40, hands down the best class ever. So it's on record. I'm glad we're recording that. Thank you all for being here. Today we have a really interesting topic to go over. We'll be talking about the architecture, engineering, and construction industry. I guess from here on out, how we refer to it in the industry is the AEC industry. So if you hear me say AEC, that is the architecture, engineering, and construction industry. We'll be looking at a project that we all know very well today. I'll let the suspense build on that because it's a project that is very high profile in Houston. It is a very challenging project that everyone will know from around the city. A lot of challenges were there, and a lot of awesome solutions were put in place. We are going to let the high-level view of how the industry works come into focus. Karim will be leading us into a presentation on that. He'll focus on structural engineering. There will be some topics that touch on architecture as well and other types of engineering, which could be mechanical, electrical, plumbing, civil. All of those things come into play. All of that being said, we're excited to have you all here, and I'll introduce more detail on Karim and his company. His company is Walter P. Moore. They started in 1931, according to their website, in Houston. They are Houston-based, and starting out doing River Oaks houses for $5 a house. So they were very small time coming out of the Great Depression, and fast forward to about 90 years, and they are in an international office now with over 24 office locations throughout the world, 6, I think, being international.
It's 30 now, sorry, Caveh.
Oh,
it just
30.
increased by 6.
Okay, well, yeah, so growing even as we speak. But that's wonderful. So that Karim also is the practice leader for the structural division here in Houston, which is where they started. So you really could not find a more premier structural engineer to educate us today on some of the challenges and awesome designs that come from the projects that he has done. He has done many high-profile projects across the city, and currently also doing many high-profile projects. I know that he is involved with the TMC3, which is a major boon to the medical center, bringing many jobs in a very challenging project. I would, even though that might not be today's topic, I would really like to tell everyone to look up the TMC3 project. It is going to do amazing things for this city in Houston, and Karim is the lead engineer on that. We're very fortunate to have Karim here. He himself is the managing director of structural engineering, like I said, for Houston. He got his degree, Master of Science, from University of Texas. Shout out to all the Longhorns. He's been with Walter P. Moore since 1999, and varying projects. He doesn't have much of a specific. He has a very broad range of experience with high rises and hospital work, and we could go on and on about his projects given the length of his career. But I will turn it over to Karim after a few announcements I would like to make as well. Some of the announcements that we have seen over the past month are one from Desmond. He shared the event for Tux and Chucks on October 15th. It's sponsored by Men Incorporated, Mentoring, Education, and Nurturing. October 15th is a day, and if you need, we can send out more information on that, but it's in the group me on how to get tickets to that event. Another announcement we would like to make is Ada. Ada has started a new fantastic job at Coca-Cola for the directing. She is the new director of public affairs for communications and sustainability, and we wish her all the best in her new role. Another new role that has happened in recent weeks is Stephanie Taylor is the new COO of the Beloved Community. Definitely check out Beloved Community. She educated me on that at a coffee recently, and that is a very cool nonprofit. Look that up for sure. Another announcement that we would like to make, this is a very big one. Dorita has been named one of the top 30 influential women of Houston. That is awesome. Dorita, I see you. Congratulations. Well deserved. Proud of you. And Dorita, you get 2 mentions because of your the launching of your 2023 NCAA Read to the Final Four, increasing literacy our 3rd graders and students is wonderful. And thank you for being a leader in that. Very proud of you for that one as well. We're very proud to call you a Leadership Houston family member. Leadership Houston Thirsty Thursday coming up on October 6th. Can't miss that. We have a lot of things to celebrate. And we have the improv showcase that is coming up, which is Sergio, Daniel, David, and Dr. John. They are doing the improv showcase. It is, oh gosh, what day is that? Is that the 26th? It's the 26th, right?
Yes, it's Monday.
Yeah. 26th at 8 p.m., $5 entry, and BYOB if you're so inclined. That is correct. Okay. And also one last announcement to make. Sergio is going to try and put together another learning experience, whether it be, one suggestion might be a cooking class or maybe some yoga classes, meditation, just as examples. If you have any ideas, let Sergio know, or myself, and I can pass the message along however you want to do it. I think that's it for the announcements. If I missed any, I very much apologize. And I guess I will turn it over to Karim so that he can educate us on the AEC industry.
All right. So thank you, Caveh, and thank you, Sergio, for helping set up this one. And I want to thank Dr. Rima for helping with some edits. The idea is just to give you a very high level overview what the architectural construction industry is, but most of the time I want to spend on the 2 projects, and we'll do the ION first. And like I mentioned in my message, Mickey Leland is the other one, just to give you an idea why we repurpose building instead of building new, and what is the benefit that we get out of it, and how the process works from the structural engineering point of view. So the focus is going to be, of course, is mostly for the structural engineering portion. And if you have any question, feel free to add that to the chat. And I divided that into 3 sections so that we have breaks to address those questions. And again, there's no set agenda. So feel free to ask anything if you have. So let me go ahead and share my screen. Let me know if you guys can see it. Let's see if I can...
Yep.
All right, so you can see the full view of the screen?
Yeah.
Okay, perfect. So how typically if you decide that you want to build a structure, right? So what is the process? So that kind of summarize it, right? we need to have some kind of a process. we just cannot throw numbers, throw ideas. You have to make it work. So what we typically do is, at least at some level, somebody has to come up with the idea. So you may be sitting with the owner and they say, hey, I mean, I need something which is this size. I want to look at this way, or this way. Right. So for this one, you can see a sketch of a building. And of course, it's very schematic. And you say, okay, how do you turn into reality? And if you go from this to this, there has to be a process. So going from the concept to the actual execution of the project, how that works. So typically in our industry, in the commercial construction, you will see two processes. One is what we call traditional design bid build, where typically owner will hire an architect, and then architect will hire a couple of engineers, code consultants, and the list goes on. And then the general contractor, the contractor will have concrete, steel, roofing, and other trades, exterior walls, things like that. The other system, which is getting more traction, it's very common on the West Coast. And we have done a bunch here in Houston, but this is getting traction where owners still have the same team member, but now the owner is only contracting through general contractor, and all trades still the same, but there's only one person responsible, is the contracting firm. So there is no finger pointing. Doesn't work in all cases, but it works in most of the cases. So the contractor is responsible for hiring the engineers and architects and their subconsultant or subcontractors. So what does an architect do? Just a joke, of course, we call them engineers without the math degree, but they do planning. So they do block diagrams. They do look at the lighting, traffic pattern, what needs to be done. So you can see that cartoon on the screen is kind of a residential area, but they will provide those block diagrams. And then from there, they will refine their drawings. They will create documents, will show the rooms, general dimensions, and they create something conceptually. This is a canopy. They will show something that, okay, yeah, you need to have something like this. So it's our job to make sure that can stand. And of course, every area is different. So you have seismic, you may have wind. So you have to design for those forces. I will not touch all the engineering, but like, of course, there's a mechanical where you have to have the air conditioning, plumbing, electrical. You have to make sure that the egress and the American Disability Act is followed, things like that. That's part of the architect, and then working with a code consultant and different engineering firms. So for our portion, so what structure engineer do? So this is our building. The picture is our office in downtown that Waterby Moore designed back in the 80s. So this is what we typically do is we design structure. So if you can think of any force, gravity, earthquake, hurricane, blast, tornado, flooding, any natural disaster that you can think of, or any loads that you can think of, we have to make sure that if somebody is drawing something, it can withstand. And as a structure engineer, the only responsibility we have is public safety. So when we put our stamp on the drawing, the only thing we are responsible is making sure that the building is safe. Whether the glass is broken during a major hurricane, or owner wants you to change something because it's costing more, but it will compromise the safety of the folks, we don't do it. Technically, we have to report that. So that's why we, as an engineering profession, we are not the fiduciaries, because we cannot. our interest is not the client. We don't hold the client interest first. Public safety is the #1 priority. So if the client fires us, that's fine. It doesn't happen often, but that's a possibility. So what type of, when we say structural engineering has a multiple things that we do at Walt Moore. So we do structural engineering, which is the skeleton of the building. Then we do the enclosure engineering, which you can see on this building. This is a federal building. So it has all the glass and all these fun stuff that you see outside that covers the beautiful structure that you don't see. And then parking design, and then secure design, where you can design for blast loading. After 1985 Oklahoma bombing, the federal government changed the rule to make sure that the buildings are safe, at least not necessarily standing intact or doesn't have any damage. The idea is that building is safe enough for the occupant to be able to safely evacuate that building. So life safety, again, is the concept. So structural engineering, again, this is the 2 projects highlighted here. One is the Puerto Rico Convention Center. You can see the shape. Yeah, it's a free fall shape, but all these steel members are working to make sure that stays intact during any major hurricane. On the right-hand side is the air traffic control tower, which you typically see a very specific box, but this is different. This looks a different design, and this is in San Francisco, and this can stand up to magnitude 8 earthquake, and it will just swing back and forth. So idea is that, yeah, you have to make sure that it's standing, and the reason it's critical because you don't want to have an air traffic control tower down during after a seismic event, because that's where you need that to be functional. So people still in the building 24/7. So you have to make sure that it's safe for the occupant. Enclosure, so you'd see that some of these, the bottom left-hand corner is a concept of a confidential project, but the other, like just the enclosure, whether it's a roofing system, coming up with like different high-profile roof covers to a skin on the building that looks something different than an ordinary curtain wall system that you see in buildings. We also do parking garages. So we have a group that does the parking design, so aisles, all the controls and everything that's done. I don't want to go over the list, but this part of the structure practice here. Secure design is the other one. The bottom right-hand corner, you see that we typically analyze based on the blast load, what is the impact on the building is, and making sure that we either create that safe zone or we use a charge. Like in this one, there's a certain charge on that building that you can safely evacuate the occupants. That's again is coming from the same concept after the Oklahoma bombing. We also do construction engineering. We have the contractor build that. Right-hand picture, you can see this is one of the connection of a truss in one of the stadium that we designed. Those connections can be huge and complicated. So those are the one that just shows you the scale of the complexity in some of the stadium that you see, especially these days. Everybody wants, like Dallas Cowboy was the extreme. I started Minute Maid was one that we did, and we would say, oh, that's pretty cool. Now it's like nothing. I mean, the people are going stretching more and more. And then we have the diagnostic practice where, of course, once you build the structure, there is going to be a maintenance. And we take that as I mean, no building is designed for forever. Every building needs maintenance. So you have to go through some places you will have problems. And then we go out and we do the investigative work, we do the repairs, and we recommend we produce document to show that how to repair that, work with a contractor. So we have a group that works on that. Also the same, we support the litigation. So somebody has default construction, then we support the litigation efforts also. Where do we work? We work pretty much all over the North America, South America, portion of South America, Australia, Middle East, some in Europe also. We have offices that now cover some of our international locations. So what type of projects that we do? So the top one is aviation, of course, commercial, cultural facility, government project. This is one of the projects that I probably will show at the end if you get some time. Healthcare, education, hospitality. We don't encourage gambling, but we design if the client asks us to do so. So we don't take any liability if you leave your credit card there. Mixed use, parking garages, SoFi Stadium, you guys have seen that at the Super Bowl that just completed. That's one of the most expensive that stadium is getting. Again, like I said, it's getting more and more crazy these days with everybody's expectation is high. The one on the bottom left one is the TMC3 that Caveh mentioned. This is a rendering. So it's like a couple of every single building is a different building. We have 3 buildings under construction right now. The rest is coming up. So we'll see which other project we'll able to do in that site. But it's a massive site. It's going to be a research hub and a major boost for Houston. So this is the structure model. That's what we do, and that's get us excited. So we go from foundation all the way to the top. You don't see that because these are usually covered by all the exterior glass, covered by ceiling, and so it's usually during construction you see that. So we analyze the structure models and making sure that this is the hospital in Phoenix. One of my project that we just completed is Women and Children's Hospital in Phoenix for Mercy Gilbert Hospital System. So we analyze, and this one was moderately in moderate seismic zone, so different from Houston, but this is just a concept. That's what we design. We take this one and we produce drawings. So right-hand side is the concrete, left-hand side is the steel building. We produce document, and then sometimes we see the concrete, and most of the people don't think, but every single mix of that concrete is designed. Every single mix has a different ingredient at a commercial construction. So you can get different variety of these concrete based on what you specify and what the building needs are. Same on the left-hand side, every single rebar is designed, the spacing is designed, and that's what we do. On steel construction, these members, including connections, different braces, floor, every single bolt has to be designed to make sure that it meets the building code requirements or for forces. So this is just like a kind of a general overview of what the structural engineering is and what type of work we do. So I will stop, pause for a minute and ask for a question.
I had a quick question. How do you normally get your projects? Or how does Walter P. Moore get projects?
So we have, like, of course, we are 90 years old. I was not here till when we opened the office, but mostly is based on relationship. So we are one of these very fortunate farms that we have these existing relationship, like Texas Medical Center. Our first project was in 1940s, and we are still there. And if you drive in Texas Medical Center, more than 90% of the buildings are designed by us. So same with major stadium. The first retractable roof in Houston was the Houston Minute Maid Park. At that time, it was Enron Field. So when I was hired, I toured the building as part of the interview process. Now we have done so many retractable. So I think it's, again, is based on the relationship, based on the expertise that we have in-house. And one thing that I always tell people is that there are people who will either under-promise, over-deliver, over-promise, under-deliver. We don't do that. We just promise what we say we'll do it. So that's what I think give us a edge to get the project, because it's just becoming a trusted advisor to the clients, and we get most of the work from the repeat clients. Any question on this?
Vouch for that. The Walter P. Moore reputation is very good throughout Houston. In the architecture community, we all know that it's one of the premier engineering firms in the city and in the country.
Thank you.
And also, Kareem, there's a question from Daniel, and he was asking about the ingredients in industry concrete. I think he's asking about like the mix designs.
So now, like if you typically get, let's say you are doing a home project, right? You'll just get it mixed concrete mixed bag from say Home Depot. And they have like different mixes, which is 3,000 to 5,000 mix design. But now with the high-rise construction, like you see, if you are driving on 610 and Emergy building, for example, right? You see that bank building. Or you see SoFi Stadium. So now we are going to 15,000 PSI concrete mix. So you have to change the mix design. The other one is we are getting more environmental conscious. The major source of pollution is CO2. So cement is the major culprit. So we try to replace the cement with fly ash. So that's one of the things that we try to do, is specify the mixes that has a higher percentage of fly ash. Then there's another thing which we call it admixtures. So it will help with the curing. It will minimize the concrete cracking. So concrete crack is like one of these facts, not the alternate facts, but the real fact. Concrete cracks, that's a fact. So the only thing we can do is minimize that, so not ordinary people can see it. We will see it, but because we are looking for it, but most of the people won't see it. Then what you do when you are pouring a concrete, when the temperature outside, it's not common in Houston, but what if the temperature outside is -28, or you are below freezing, or what you do when you are 105? Concrete doesn't work that way. So you have to have ingredients in there that can take that hot and cold weather concreting. So there is a criteria that we specify what you have to mix in there to make sure that it's doable. The second is when you do that much strength, usually water gets to be lower and lower. So how you make a mix to flow through these rebars and still make it work. So that's where different mixes are applied. Good question.
And thank you, Kareem. That was a very good answer. And also for Rima, she was asking if you do residential designs.
The introduction that Caveh said that we started with $5 a piece, we don't do that anymore. To answer your question, Rima, the residential part, we only do when a project is a lease space. We don't do condominiums because the only condominiums we do if it's part of a hotel system like Four Seasons. If they have a hotel and then condominium on top, because Four Seasons is the one maintaining it. Some of the association, homeowner association, and you probably guys have remembered a couple of months back, there was a condo collapse in Florida. So that's one of the reason is the condominium gets to be really tricky. So we have a risk review panel. So condominium is the word that we don't use it because it's just a lot more liability than the benefit. But if a building is as a high-rise residential is for lease and there is no condo board, then we will do it.
I think David has a question.
Yes, sir.
Hey, Kareem, I don't want to put you on the spot, but I'm going to kind of put you on the spot. So
Sure.
Speaking of condo buildings, so Houston about a month ago or so had a condo building that had some structural issues, I guess is the best way to put it. 3333 Allen Parkway, and everybody's, obviously had to move out. So what's the due diligence process now to try to figure out, what happens next? What does that look like?
So the first thing was I think an overreaction because of the what happened in Florida. So there was actually a pipe burst and part of the slab bulge, and that was not necessarily a failure of the building, but they just did out of precaution that they didn't want it to repeat what happened in Florida.
Sure.
So it was a kind of that was what it was not our building, so we didn't get involved in that one. But that's what the reason was, that the pipe burst and it just flooded the building, and the one of the slab portion bulged, and people thought that the building is collapsing. So that was not necessarily the case. But due diligence, what we do is the diagnostic portion that we do, we have like for every major institution, the buildings that we do maintenance program where we will go at a certain frequency based on the life of the building. If it's new construction, maybe every year. If it's an older structure, every 6 months or so, and we will do the visual inspection. If we find issues, we will do further investigation and then we repair it. The unfortunate thing on some of the condo project is that's not necessary is their part, because if they will not implement the maintenance, that's first thing that you have to do, like you do for your house, right? If you live in a house, you will make sure that you have to do roofing inspections, you have to do the window caulking, things like that. Maintenance part of the life of the structure. So if you don't do that, that's always gets you in trouble.
And one last question from Dorita was if Walter P. Moore works with hub firms, and if you wanted to talk about that.
So Walter P. Moore does work, and we've been working with hub farms on most of the project, and we do a lot of work with University of Texas System, MD Anderson. So state has the requirement, and even though without the state requirement, we do partner with the hub farm in Austin, Martinez Engineering, and we whenever we deliver major projects where there's a hub requirement, and now, like I said, it's becoming more. So we created a partnership with Martinez Engineering as a Walter P. Moore Martinez Engineering partnership, and it's called Martinez Moore. So it's Martinez Engineering and Walter P. Moore. So it's Martinez Moore. So you will see MME instead of WPM. That's Walter P. Moore and Martinez Engineering working together. So we have that partnership on all our projects. We had before, Nathalie Kennedy was one of the hub firm that we used. If anybody from Prairie View A&M University, they know that that's the name of the architectural building is after her name, is the Kennedy building. So she was one of our hub partner also. So yeah, we do work with hub firms.
Hey, if there are no more questions, Karim, do you want to move into the next part?
Sure. So let me go ahead and close that one. Let's see.
This next project should look very familiar to us all.
So let me know if you can see the Sears building with the full screen.
We see it.
You can see it? Okay, perfect. So we all were at the ION building during one of our class. So I just thought that probably it's better to show that building where we all were and how it changed from what it was before to what it is right now. So the building was done in 1930s. So this building is being there from very beginning. So it was a nice building. You can see a lot of glass, welcome entrance, and it was a nice addition to downtown. During 1960s, for some reason, they tried to use a different type of facade and covered that. So still not too bad. If you look at the first floor, it's still a lot of glass, a lot of lighting, open space. And then in 1980s, you can see the first floor covered with brick, and it looks like a dungeon, but it may be a security reason, whatever it was. But this was the 1980s of the same Sears building. And this is what the 2018 building looks like before the ION was built. So pretty depressing building. And Rice owns the property since 1930s, and they leased the space to Sears. So then Rice decided to make this an innovation hub. So we were hired and we worked with different architectural firms. And we created, so the idea was how you take this one, and hopefully everybody remember, I have some rendering at the end, to the one that we saw. So we create a physical model, right? So how you open it up, that this dungeon-like building becomes innovation, hub for innovation, right? So give me a minute. So you try to work with the existing structure, you open it up as much as you can, and then you add structure. And then this is what the building model looked like. And it's very close to what we saw when we were there, right? So this is the first part. So you create those physical building models and see how it works. And then the other one is, let's see, I think I have to go. Okay, so this is during construction, but you can see some of the facade members were used the same concept from their 1960s theme. They took some of these perforated, twisted metal panel and added to the building. So how you bring light to the building, which is dungeon, right? So you see this one is again is the animation. You have to cut the structure and build a light well so the building can get the light. So the building doesn't look like a dungeon. It's open, it's welcoming. So that was where we created the structure, and it's a 1930s structure. So it's an old building. So modifying was challenging. But you create that light well, and at the bottom you see that steps. Those were the one where we had our class. If you remember that we were in the conference room and we went everybody was sitting on these steps for one of our exercise. And then we create these physical models just to see how, if the light is too much or not, but just taking that into consideration to make sure that we know what we are doing we are not creating something, and especially in Houston weather, you don't want to create something that's going to create adverse effect of, instead of lighting, you're getting heat. So this is again, same concept with the skylight, new skylight that was installed on top. So in this picture, everything that's blue is the new structure. So we repurpose majority of the structure, but we have to cut structure. So you see some of these columns right here that we had to add, and you can see in the actual images that how we had to add this one to make that part of the design, but also to support the structure. The other challenge was all these blue, the top is all steel, the bottom is all concrete, but you have to make sure that this blue and this gray all looks the same, even though this is done in 1930s and this is done in 2020. It has to look like the same because you want to create the same space. You don't want to have this look like a pad job and everything is exposed. So that was part of the challenging part. So why we didn't demo and build the new one? We say 3,100 tons of CO2. That was one of the reasons. You repurpose a building because you can make an impact on environment. So this is where, and there I can share if people are interested, but this is why we try to repurpose a building instead of building a new one. And then it create a character. It is in Ion is famous not because it's a new building. Ion is famous because it's an old Sears building. So this was the rendering. Again, this is the rendering, and this was a class where we all met. So this was what it looked like when we went to the space in 2018. Pretty depressing. There's no steps, nothing, right? So you have to cut the structure, create something. So we go through every single corner to make sure that we don't miss anything, because we have to make sure that it can stand the forces that's needed to stand for the new building code and life safety and everything. So 1930s to now, the building codes change a lot. So we look at, again, when we are looking for the stuff, we will see the cracking. Most of the time people will miss that, but we actually go there and look for issues. And when we remove the skin, this was the building. So you can see that it was a challenging part to make that work. And we always tell people like, yeah, I mean, this is something that if you can repurpose that, it probably costs about the same, but you can make an impact. And that's what Rice decided to. So we take the old drawings from the 1930s. And of course, these buildings, we are adding additional floors. So we have to go and strengthen the building to make sure that can not only withstand new code, but we are building on top of the existing building. So we don't want to have the certainly the foundation sinking into the ground. So we look at these, we design the details, and then the construction happens. This is everything was done. Every foundation was checked, every column was checked for the existing building to make sure that it's safe. This is another one that right-hand side is the steel structure that was built on top. On the left-hand side is the concrete wall where you can see a bunch of reinforcement and everything was done, and concrete was poured inside a building, which is not usually easy to do, but these guys were skilled to do that work. So the existing roof on top of the existing building, which you can see the arrow there, it was not designed to be a walking surface. So we have to build a roof on top of a floor on top of the existing roof. So we have to build that out of steel. And the picture on the left shows what we did, the framing on top of the building. And then some of these walkway again, just some of the details that we have to go through to make it work. And this is what I was talking about before, is the new portion, and part of on the left-hand side, you see the existing building. When you walk in that space, every concrete is exposed, right? So you have to make sure that the old and the new looks about the same. So people don't see that as a patch. So it was done, of course, we have to match the concrete texture to make sure that it works. This is during construction, they were installing the metal panels. This is that huge skylight that brings the light. Once we cut the structure, this is the skylight that was installed. And then you can see that it's installed in a way that it brings the light, but not necessarily direct sun to the space below. So that's why all these models was created, to make sure that you look at not only the light, but also the comfort level, so that people can use the space. So this is what it looks like. These are the columns. You can, if you see or remember, these are the rods. These are the column that's supporting the edge, because we cut the center of the structure. But those were the support needed to make that building work. Another view, again from the sides. So going from a 1930s building to this building, yeah, I mean, you can build within this about the same cost on new building, but the reason it's famous, again, like I said, it's because it's an old Sears building. And people love to use that building because it was repurposed. So any question on that one?
Yeah, I have a question. Sorry for chiming in late, but are there any also cost savings, or I guess what is the comparison between this and starting from scratch?
I mean, you can save cost, because again, you're not, depends on how good of a condition the existing building is. There was some challenges, but not everything was bad. I mean, you saw the picture. There are a portion which requires significant strengthening and some foundation work, but you still are repurposing a bunch of stuff that, so there is some cost saving. But you have to look at the total cost, because not only material cost is one, but you're saving a lot of schedule time also, because you're not building half of the building. It's already there. So building versus strengthening, yeah, it's a time saving too. So cost, environmental impact, initial cost, and then this space they can lease for a higher price, there's a lot of spaces in downtown now available. But if the space available in Ion, that usually is the first choice, just because of the nature of that building. So they can ask for premium cost for rental or leasing spaces too.
I believe we have a question from Landy.
Hey, wow, Kareem, I'm I'm so excited by all this information. I just had a couple of questions related to one, not necessarily this specific building, but I hear about like LEED buildings, right? Can you talk a little bit about the tie-in, I guess, there? And I don't know if we're like LEED 2.0 or 4.0 by now. So the tie-in there. And then when I'm thinking about environment and sustainability and things of that nature, as a firm, it sounds like you all are voluntarily doing some of these things. And I'm curious, ESGs and things like that on these corporations are now being put into place. And I'm curious as to, are you all doing it literally because it's the right thing to do? Is the industry changing so that we can protect our environment more? And can you just speak a little bit more about just the elements of sustainability, because you all are, again, as Caveh said, leading the way?
So first is the LEED, of course. We all in the office, most of us are LEED accredited professionals. So LEED is the leadership in environmental and engineering design. So what we typically, these are buildings, again, decision at the end of the day boils down to the cost, schedule, and environmental saving, and the owner has to agree to that. So this is the driver. So we do in our office, we have a sustainability group, and our director of sustainability is in Austin, Dirk Kessner. He's pretty involved, and we are part of that 2050 promise of reducing the CO2 to a certain limit. So we are working towards that goal. So our portion is repurposing a building gives you some LEED credit. A lot of LEED credit comes from this different part, and Caveh can chime in also, is how efficient your MEP system is, how much natural light you can bring in and reduce the electricity, what can be done to still have a comfortable space but reduce the dependence on air conditioning, how much material new construction material you take it from the local source versus shipping from overseas. So there's a whole lot of factors. And then construction practice, how much waste you are dumping into environment, how much of these you can repurpose, even furnitures, what you can do. So I think there's like for LEED to, and one of the building that we did in downtown, which is Bank of America, if people who are in downtown is familiar with that, was done by a developer, and the contract is Skanska Corporation. And it's the first LEED building in the country. And now it's Bank of America Tower, because Bank of America wanted to use one of the building to showcase that they are in a environmental friendly building. But there is, of course, some cost associated with that. We do it as a structural engineer. We look at the mixed design. First example, concrete. We'll reduce as much cement as possible and replace with fly ash, which is more environmental friendly. We will try to use whatever we can use to repurpose the cost. In our spec, we'll require that the steel cannot be shipped from at certain distance if there are mills available. So that's part which is, again, is a combination of things. And when I show the chart, there were multiple categories that brings that LEED credit. And you can go from LEED certified, which is the basic one, LEED silver, LEED gold, LEED platinum. So USGBC, which is the United States Green Building Council, they rate those buildings based on different type of points that you want to capture. So you have certain points that you can get as a minimum, so you are LEED certified. And some owner, they don't want to actually pursue that because of the initial cost, and they'll just say, do the right thing, and we'll just do it. And they don't worry about getting the LEED. But I think it's more and more cooperation, and people are getting educated. That's becoming something that people try to do it.
Yeah, those are all very valid points. And I think Landy, to also answer your question further, I believe that you know, a lot of the building codes are inherently graduating to more environmentally friendly standards, to where you have to, per the code, even practice. You have to practice more efficient energy requirements, whether it's insulation use and electricity use. And then yes, LEED can take that even further and do more. So I think a lot of things are being done, and there's also, like Karim mentioned, there's both a 2030 and a 2050 initiative that many industry experts are trying to achieve by using buildings as a way, or designing buildings, I should say, as a way to reduce carbon emissions.
Thank you for all that information. Just one other really quick question. I know you have more presentation to give related to that. My question kind of was related to that, you know, is this an industry standard? And I think you said, no, you all are leading the way by choice, and it is definitely up to the owner. So
Right.
that's good to know. My other question is related to, you and I, Karim, have spoken about ACE. And so, you know, ACE, I know, is a good entry point. If you could talk a little bit about that for those of us who are, you know, in education and have children and, you know, may not know that this is like what you all are doing is this amazing. I know what an architect is, but wow, I didn't know this level of, you know, making decisions is possible. Can you talk about that as it relates to the fact that we are in Houston, and this building that we're looking at on the screen is, you know, the Center for our Innovation? How do we bring in and leverage this diversity to all of these, you know, how do we reach more and expose more so that more feel welcome and belong as a part of, you know, some of you all's efforts, because what you're doing is amazing stuff.
So just briefly, ACE is the program that Architectural Construction and Engineering firms from all around the country. They started that program back in 2014, and we participated that, and then we expanded that. So what we do in very brief, high-level overview, we ask different schools, and mostly the areas where people are not exposed to these type of things, especially the areas where you have the minority participation, you have people or students never been exposed to any of these things in their classes. So we do bring those students. So Walter P. Moore host during every year we do that program, and this year Rebecca Conrad from our office is leading that. Every year we have somebody from Walter P. Moore is leading the effort from our side, and we have contractor, we have architect firm. They partner with us. We bring the student, we train them, and then we give them a project. And we every week we meet with them and give them the guidance how you are going to build that building, come up with ideas. And we will provide, we assign mentors, and they can ask the question, and then we do the competitions, and they will come up with budgets, they will come up with schedule, they will come up with design. And of course, some of these are not practical, but that's the idea. Let them come ask the right question, let them come up with their imagination. And then we do that at the end, you do that competition, and I have judged those competition. There's a lot of talented student, and there are a lot of talent that comes out of those programs. And then there's a scholarship at the end for the winning team that come up with the idea that's more practical, that meets all the requirement of what different criteria for judging is. So it's a couple of months exercise that brings that knowledge to these students, and they start thinking about how to take a dream and make it a reality with the budget, schedule, construction, everything scheduled. So that's the program for, and we are just starting the next session. And if you need Landy more information, I can connect you to Rebecca from our office. She is a great resource to help you.
You know, and also something, Karim, I'd like to add to this specific building is, you know, as you were showing the diagram of how you were adding the blue areas, it to me, I can't stress enough to everyone here who's listening that when you take a building from the 1930s and then you add a structure on top of that that is different than the original structure, how you grandfather a 1930s design with a 2020 design cohesively to make it pass life safety standards, I can't tell you all how hard that is and the level of expertise that it takes to make that happen. So I mean, it's a very impressive project, and how you're able to bring light into a dungeon and also add 2.5 stories on top of it is it's a wonderful job. I can't say enough about it. And then I believe I'm seeing Rima has a question.
Real quick, Karim, thank you for presenting. This was a job well done, excellent. I was just gonna say, if you are able to come to Houston Community College, because we have an engineering program, and present it to our students, we can organize your lecture.
Thank you. I hope it's not a lecture, but I'm happy to come.
Yeah, these
thanks for
kind
the-
of things, they don't teach us, you know, in the classroom, but I think it will add a lot of value.
Sure, definitely. So what I will do is I will quickly show the last one. I know we are getting to we have a few minutes left, and I'll just quickly show the Mickey Leland project. It's not as fancy as this one. It's just PDF, so bear with me. So I have to can you guys all see my screen?
Yeah.
All right. So this is the Mickey Leland Federal Building. For some reason, I lost the other screen, but that's fine. Just let me know if you have any technical difficulty. I think my computer was acting up. But this was another building that we repurposed. And this is just the PDF. So this is, if you guys remember, this is Pierce Elevated. This going to Dallas, I-45 North through downtown. The federal building is on one side, their parking garage on the other side. There's underground tunnel, and then you come up and go through the breezeway. This is the building where the passport office and IRS and everybody have their offices. So this is what the building looked like, a 1983 office building. And it was a precast construction, typical office building, nothing special about it. But federal government bought that in 1986. And like I said, after 1985, Oklahoma bombing, a lot of things have changed. So they decided in early 2000 to modernize this building to make sure that it can resist the blast loading, it can resist the wind loads, it can meet the new building code requirement, and it looks nice. So this was, so they did a couple of different iterations, but having an 83 building, even in this case, was not easy to renovate because of how it was constructed. Some of the specific I will skip because it's a federal building and we have to sign the NDA. So I don't want to end up in jail after this presentation. So I will keep that vague. So apologies for that in advance. But this was not designed for modification, but the modification that the government wanted. But we still wanted to give them something that's still state of the art, still meets the security requirement, and still meets the building code. So let's see. Sorry, I thought it was a presentation. Let's see. Go back. So this was the building before. Again, this is the garage schematic diagram. This is the garage right here. This was the lobby, a very small lobby space. People will, it looked crammed if anybody here went to the passport office before. This is one of the highly dense building. It has about 1,100 occupants. And the idea was that when we do this renovation, we were not supposed to relocate any of the tenants. They can still stay in the building. So that was the challenging part. So of course, it needs to be energy efficient in addition to all this stuff that so the federal government wanted change that building to this building. Of course, we told them we are engineers, not magicians. So we gave them that this is not possible, but we can give you something slightly better what you have. So we took that old building and we proposed something this. This was with Gensler Architect in Houston. So we said, okay, this is underground tunnel. People come in this nice glass breezeway. There's a green roof on top. You will have new cladding. We will add security so it's protected against the threat that government wants to avoid. And you can have something like this. So they agreed and we did the analysis. The first thing was, can this building get this modification? And that's where the structural engineering part was. So we worked with the design team. We created that concept model. This was the original footprint of the building. We added a lobby space. And then some of these areas, which is part of the green space, and I'll show you a rendering, not rendering, but the actual picture. These are the security barriers that we added around the building without going into specific to tackle different threat level that the federal government provided us to secure that building. So this is again some rendering. So this is what we propose as a lobby space in the rendering. So this was the structure part. The building was not actually straight. It was slightly tilted. It was safe. I mean, it's exaggerated, but we had to build a new skin which is straight on a building that was not straight. So this is the part which is the structural engineering part, was the complicated one, to make a building take the blast loading, take the new wind loads, still meets the new building codes built in 83 with no provisions or modification. So we came up with details. This is one of our engineers on site, and I was there because it's downtown, so I was there multiple times during the construction, because especially this corner right here is the reason I have gray hair. Took most of the time because it was complicated to design. Just the nature of the building was not there to modify, but we were able to design that. So again, some of these details, we have to chip exist even portion of the concrete in a way that we don't impact the occupant within the building, because this was fully occupied building during construction also. We created these security barriers that you will see in a minute. Green roof again, just collecting all the water and making sure that we are not only providing the building as efficient, but also the rainwater tank and everything was added to collect water from these green roofs. So this is the building looks like today. If you drive on downtown, you will see that in the corner. Again, state-of-the-art build skin. This is designed to resist the threat level that was given to us. And these landscape features are part of the security barrier to reduce or minimize that threat level that the federal government wanted to achieve. And across from there in the garage, we added the solar panel, and the solar panel traveled through the tunnel. The building is getting part of the electricity out of these solar panels. This is the extended lobby space, and you can see before and after picture. This is the breezeway, again, creating something that welcoming for people coming from the tunnel. And this is what the lobby looks like. This wall right here was a lot of designers, and especially minority architect, they came up with different design on the lobby space. So this is what the end lobby looks like. So sorry, this was a very fast pace, because I know we are out of time, but any question on this one?
No, Kareem, I was just making the comment in the chat box that it's nice that you're, you know, when you're designing these, you know, quote unquote barriers, but they're still designed to be a design component that's welcoming, you know, it's not just this
Right.
wall, right? You know, yeah, so it still performs its function as a barrier, but while it's not protecting something from something happening, it's something people can use, which is wonderful.
Thank you. Any other question? Thank you, Landy.
Yeah, if there are no more questions, I want to personally thank Kareem for educating us on this fascinating industry, AEC
Thank you.
industry. And say that as an architect, I can say that we absolutely could not do anything without the expertise of people like yourself.
I'll take the joke back, Caveh. You know, mathematics drill.
Now, I know that we just deal in, you know, markers and popsicle sticks, and you have to make it work for us, and that's fine. But thank you very much, everyone, for being here, and I hope we all see you soon. And thank you, Andy, for recording, and we'll send that out to everybody.
This is really great, everyone. Thanks so much.
Thank you.
Take care. Have a good day. Bye-bye.
Bye.
Take care. Bye.